Hello there! We have finally arrived at the last lesson in Chapter 3. This was almost as long as Chapter 2. Wouldn't you agree? Not quite though. Alright, today it's all about inverse variation, which we already have been learning about direct variation. This is its long lost cousin. They're kind of related, but opposites. You know how that goes with family. Alright, the equation for inverse variation is y equals k divided by x. And it makes sense that they're opposites, right? Direct variation, you're taking k and multiplying it by x. And in inverse, you're taking k and dividing it by x. So many opposites in math. K can't be 0, though, so they do still have some things in common. So we want to be able to identify inverse variation from an equation, from a table, from a graph, just like direct variation. So we're going to start with the tables. When a relationship shows inverse variation, then x times y will be able to always give you k. And what that means in terms of a table, I know when things show direct variation that the cross products were equivalent. If something is inverse, then when you actually multiply the x by y, you're going to get the same thing every single time. So again, when x times y gives you k, every time there's an inverse relationship going on. Alright, so testing it out, 1 times 36 is 36. What's 2 times 18? Yeah, it's 36. What's 3 times 12? 36. What's 4 times 9? 36. What's Mrs. Trombley? Almost 37, but right now, 36. Alright, so this one right here, this is a yes. It's a yes because x times y gives me the same product every single time. Alright, take a look at this one to test it out. 1 times 12, it's 12. 2 times 6 is 12. 3 times 4 is 12. 4 times 3 is 12. This is also a yes. Now, if I show you a little blast from the past, you don't have to flip back, but I'll show you really quick. I'm going to go back to our direct variation lesson really quickly. This is direct variation right here. The previous lesson, 1 times 10 is 10, but 2 times 20 is not 10, and 3 times 30 is not 10. So you can see that it doesn't happen every single time just because my 2 examples did. You always have to look for it. So in both of those were both yeses. X times y equals k every single time. Alright, now I'd like for you to look at how to identify inverse variation from an equation. We said that an equation is inversely proportional or shows inverse variation. So we've seen this proportional. Now it's inversely proportional. That's another way to say inverse variation. It takes the form of y equals k divided by x. So we'll show you the inverse examples first. So these are the actual examples that work out. Again, they need to be solved for y. So in this one, y is by itself, and there is a number k being divided by x. Same thing, y and x stay letters. There just needs to be a number in the numerator spot being divided by x. So this is a yes. In this next one, x times y equals 2. Before you can determine this, you need to have it solved for y. So, divide by x. X divided by x is 1. 1y is y. And we don't know what 2 divided by x is, so we just write it as 2 divided by x. So you see how this is y equals some number being divided by x? So yes, that is an example of inverse variation. Alright, last one here. I have y divided by 5 equals 6 divided by x. Now we want this solved for y, right? I know you're used to doing cross products, and that's definitely one way to do this, but I would actually just use your multiplication property of equality. If y is being divided by 5 and I want y by itself, can't I just multiply by 5? So multiply this side by 5, and the 5's will cancel out, right? Because that's really like 5 over 1. And y is alone now. If you multiply this side by 5, we need to multiply this side by 5. 6 times 5 is 30. X times 1 is x. And hey, it equals some number being divided by x. So all 3 of these can be written in the form of y equals some number k, that's not 0, being divided by x. Now let's take a look at some of the non-examples. Right, in this first one, 5y equals x, we need y by itself first. So we're going to divide both sides by 5 to get y alone. And this shows y equals x being divided by 5. This isn't the same as 5 divided by x. Remember, when you divide, order matters. So because the x is in the top spot instead of the bottom, this would actually be proportional, not inverse. All right, so this is a no. Over here, we need to get y by itself. So I would add a -7. So negative x plus -7 would equal y. This one right here does not have a number being divided by x. So that's a no. We need to have y equals some number divided by x, not adding a -x. All right, last non-example, I have 1/5 y equals x. I need y by itself. We learned to get rid of a fractional coefficient. I can multiply by the reciprocal. So I would multiply it by 5/1. They all cancel out. And we can multiply by 5 or 5/1, same thing. And x times 5 is 5x. So again, that's a direct variation. This is x being multiplied by a number. I need to be dividing by x, not multiplying by x. So that's why those are all no's. All right, turn the page, and the last thing we have to do for the whole chapter is to look at the graph here. All right, so identifying inverse variation from a graph. Basically, when you have inverse variation, this graph is a nice smooth curve, and it can never touch the x or y axis. It cannot touch that. And we'll talk more in class about why that happens. We're going to do a little exploration with rectangles if we haven't already done so yet, that will explain it a little bit better. But basically, this is not a straight line. This will never touch 0, 0, because this is not direct variation, it's inverse variation. So an inverse, it's going to be a nice curve. All right, now one last little thing I'd like you to be able to do, and just to clarify, both of these are a yes, because they are both a nice smooth curve that will never pass through 0, 0, or touch the x or y axis. What I would like us to be able to do is to write an equation for each of these graphs. And it might seem like pretty far-fetched, like how am I supposed to do that? Well, I give you an ordered pair right here, right? And if you recall, in an ordered pair, it's x then y. Okay, so we said that in a data table for inverse variation, that x times y equals k, right? And we know that an equation for inverse variation is y equals k over x. And all you have to do is figure out what k is. So if y equals k over x, and all we need to know is k, and I know that x times y equals k, we could totally write this equation. If you haven't figured it out yet, it's okay. But if x times y equals k, wouldn't k here be equivalent to 1 times 5? Right? So k equals 5. If I know that k equals 5 and y equals k over x, then my equation would just be y equals 5 over x. Bam! We just wrote an equation for that graph. All right, take a look at the next one. Maybe hit pause for a second, see if you can figure this one out. I want an equation in the form of y equals k over x. X times y gives me k, right? X times y gives me k. If x is 3 and y is 2, then k must equal 6. So my equation for this graph is y equals 6 over x. We just took it one step further. All right, the end of chapter 3. See you next time.